Hello friends, today we will be discussing the last unit of the subject 2BS05, that is numerical methods in manufacturing, and the unit that we are going to discuss is numerical solution of ordinary differential equation. Here we want to find out the solution of the form first order differential equation of the format f x y dash equals to 0, or the equation of the format dy by dx is equals to f of xy. So both are the first order differential equation, but here we add one more condition with that, that is, if you have dy by dx equals to f of xy and we want to find out the solution, it is some condition given to you that y of x0 equals to y0, then this becomes the initial value problem, and here we are going to discuss this type of problem. Now here also the points which we are given to you is x0, x1, x2, and so many points are given to you, where xi plus 1 when you want to find out is nothing but xi plus h, means the points are at the equal distance. Different methods are available. Out of that, the first method that we are going to discuss today is Picard's method. Picard's method of successive approximation. In this method, again we want to find out the solution of the differential equation dy by dx is equals to f of xy, that is f of xy is the function given on the other side. Again the condition is given as y of x0 equals to y0, that is the condition. Now to get the solution we have to go for the first approximation. In the first approximation, for that we use the integral equation. Integral equation y of x is equals to y0 plus integration x0 to x given function, that is f of xy. Yes, that is how we go for. Let us say this is equation number 1. Now for first approximation, we put y equals to y0 in the function f of xy. So from 1 what we get is this, that we get y1 of x is equals to y0 plus integration x0 to x f of x comma y0. Yes. Similarly we get the second approximation as y2x, and that y2x will become y0 plus integration x0 to x f of x comma y1 dx. If we go similarly in this process, what we get is that k plus 1th of iteration of this will be yk plus 1x will be y0 plus integration from x0 to x f of x comma yk. So this is what we have to do, and this iteration we will do up to the desired accuracy is obtained. Now let us try to see this by means of an example. Let us keep this formula with us. So say in the example, solve the equation dy by dx is equal to x square plus y square, and we want to find out the solution at x equal to 0.4, and condition given to you is, the given condition is y of 0 equals to 0. That is the condition given to you. We want to find out the solution using the Picard's method. Let us go up to at least 2 approximations and see what we want to get. As we know, this is the formula y of k plus 1. This is the formula we have, y of k plus 1, x is y0 plus integration x0 to x. Now as we proceed for the solution part, of course by Picard's method the highlighted part is there. So we start with y1x. Here we know that x0 is 0 and y0 is also 0, which is given here, that x0 and y0 information is available. So we go for the first iteration and we go for y1x. So y1x is y0, but y0 is 0, so no need to put that value. But for the first iteration I am putting it. Integration from x0, that is x0 is 0. So let us put that value. So it is from 0 to x. Function is x square plus y square, that is my function. So it is nothing but x square plus 0 because y is 0. So let me put this way, x square plus 0 dx. So on simplification it gives you x cubed by 3. Now for the second iteration, when I go, it is y2x is again 0. I am not writing now, it is 0 to x square plus the answer you have got. This is your y1. So when you put that value here, we get x square plus x cubed by 3 and dx. Finally, when you do the simplification, the answer that you get means after all the substitution and integration, you get x cubed by 3 plus x raised to 7 upon 63. We can say that this is the approximate solution of this differential equation. So now you want to find out the solution at x equal to 0.4. We said that y at 0.4 will be, here we are going to put the value that is 0.4 raised to 3 by 3 plus 0.4 raised to 7 upon 63, which in turn gives you the answer at 0.0214. So this is how we are going to find out the solution. Let us consider another example. Solve dy by dx equals to x plus y, where y of 0 equals to 1 using Picard's method. Also we want to find the solution of y at 0.1 and 0.2. So let us recall that by Picard's method, when you want to find out yk plus 1, this is the formula that we are going to use. Yk plus 1 equals to y0 plus integration x0 to x f of x yk dx. Yk is the information that we have obtained from the previous approximation. Now in this case, as we can see, this is our f of x plus y. So f of x y is x plus y. From this we get y of 0 equal to 1, that is x0 equal to 0, y0 equals to 1. So when you put that formula, we get y1x is 1 plus integration 0 to x plus y, that is x plus 1 dx. So on simplification we get 1 plus x square by 2 as the answer of y1. When we go for the next iteration, it is y2. y2 is 1 plus integration again x0 to x plus this answer, that is 1 plus x square by 2 dx. So when you do the integration, what I get is 1 plus x square by 2 times, that will become u x square, and finally we get x cubed by 3, that is x cubed by 6, as 2 is already available. So this is how we get the second approximation. Now this part, find the value of y of 0.1 and 0.2, that you can do simply yourself. So this is the first method, Picard's method of successive approximation. Next time we will be discussing the one more method,